At the end of the 19th century, humanity stood closer to disaster than ever before, not because of war, not because of disease, but because of something far more fundamental. Food. For thousands of years, agriculture had sustained civilizations. But now, the system was breaking down. Fields that once produced rich harvests were turning weak and exhausted. Farmers were pushing the land harder than ever, yet yields were falling. Scientists and politicians in Britain, Germany, and the United States began to realize the terrifying truth. The planet might not be able to feed its growing population. The future looked like a dystopian nightmare. Wars over food, famine across continents, the collapse of progress. The irony was cruel. The key to life was everywhere around us. The air itself held the element plants needed most. Nitrogen. It makes up nearly 78% of the atmosphere, yet crops were starving, because plants cannot use nitrogen gas directly. To them, it's locked away, unreachable. Only rare natural processes, like lightning or special bacteria, could convert it into useful forms, and nowhere near fast enough to support industrial civilization. Humanity was surrounded by abundance it could not touch, and time was running out. Long before modern chemistry, farmers fought soil exhaustion the only ways they knew how. They burned forests to release nutrients into ash. They spread manure and compost. They buried fish in the soil. They crushed bones, horns, and hooves into powder. In some places, even human waste was returned to fields. It helped, but only for a while. As populations grew and cities expanded, the natural recycling of nutrients broke down. Waste accumulated in urban centers instead of going back to farmland. The cycle of life was severed. So nations became desperate. Britain imported bones from all European battlefields to grind into fertilizer. Yes, the remains of soldiers became nutrients for crops. Then came guano, dried bird droppings from islands off Peru. Rich in nitrogen and phosphorus. It triggered a global fertilizer gold rush. The United States even passed laws allowing citizens to claim islands with guano deposits. Wars were fought over bird poop. When guano reserves dwindled, the world turned to Chilean nitrate, a mineral also vital for explosives. Control of it meant both food and military power. But these resources were finite. Scientists feared the nightmare scenario. The moment humanity would hit a hard limit. No more fertilizer. No more food. Mass starvation. In the early 20th century, one chemist believed the solution was not in islands, bones, or deserts. It was in the sky. His name was Fritz Haber. He set out to achieve what many thought impossible: to pull nitrogen from the air and turn it into ammonia, a compound plants could use. The challenge was enormous. Nitrogen molecules are incredibly stable. Breaking them apart requires extreme conditions. Haber experimented relentlessly. High temperatures. Crushing pressures. Endless trials with different materials. Years of failure. Then came the breakthrough. By using a catalyst, a substance that speeds up chemical reactions. Haber made it possible to combine nitrogen from air with hydrogen to form ammonia. In 1909, he demonstrated the process under intense pressure and heat. It worked, but a laboratory success was not enough. The world needed this at industrial scale. That task fell to engineer Carl Bosch. He developed massive steel reactors, high-pressure systems, and durable catalysts. Together, their work became known as the Haber-Bosch process. For the first time in history, humanity could make fertilizer from air. In 1913, the first industrial Haber-Bosch plant began operation in Germany. It changed everything. Synthetic ammonia production meant fertilizers no longer depended on rare natural deposits. Asterisk crop yields surged. Food production expanded at an unprecedented scale. This breakthrough supported the population boom of the 20th century. Asterisk today, scientists estimate that roughly half the nitrogen in the human body comes from food grown using synthetic fertilizers. In simple terms, billions of people are alive because of this invention. The process is often called the most important invention of the 20th century, but history is rarely simple. The same chemistry that feeds the world also produces nitrates, essential for explosives. Asterisk during World War I, Germany used synthetic ammonia to manufacture munitions. Despite blockades, agricultural salvation and industrial warfare were born from the same reaction, life and death, bound by chemistry. Fritz Haber did not only pursue fertilizers during World War I, he became a key figure in Germany's chemical weapons program. Asterisk. He oversaw the first large-scale poison gas attack at Ypres in 1915. The same scientific mind that helped feed humanity also helped create modern chemical warfare. His life grew darker. His wife, horrified by his involvement in gas warfare, took her own life. Asterisk years later, the pesticide Zyklon developed under his institute would be used by the Nazis in death camps, even against relatives of Haber himself, who was Jewish. How do we judge such a man? A scientist who saved billions from starvation, a pioneer of weapons that killed thousands. Hero, villain, both. The Haber-Bosch process transformed civilization. It ended the fear of global fertilizer shortages, but created new problems: environmental pollution, ecosystem damage, and dependence on industrial agriculture. Humanity learned to take nitrogen from the air. Now we must learn how to live with the consequences. For most of human history, the sky was untouchable. It gave us weather, storms, lightning, breath, but one thing it would not give us was food. Nitrogen filled the air above every field, every village, every city, and yet it remained locked away, beyond the reach of life, until we broke the lock. The Haber-Bosch process did more than create fertilizer. It changed the balance between humanity and the planet itself. For the first time, food was no longer limited only by nature. We could manufacture growth, manufacture abundance, manufacture survival. Billions of people are alive today because of this reaction. Entire nations exist because we learned how to turn air into bread. But every power comes with a shadow. The same chemistry feeds crops and fuels explosions. It sustains life and has ended it. It helped humanity escape famine and tied civilization to factories, fossil fuels, and fragile industrial systems. We solved one crisis and created new ones: polluted rivers, dead zones in oceans, disrupted ecosystems, a planet overloaded with reactive nitrogen. We learned how to take from the sky. Now we must learn restraint. Fritz Haber's story is not just about one man. It is about us. Our brilliance, our ambition, our blindness. The question he leaves us with is not whether science can change the world. It is whether we are wise enough to live with the worlds we create, because the air above us is no longer just nature. It carries the fingerprints of humanity.